What we're going to go over today is trunks and access ports, what the difference is between the two and how you would use them. As networks get larger, the need to separate broadcast domains increase. There's a lot of multicast and broadcast traffic that happens across networks. And as that evolves, you need to break up those broadcast domains so that it doesn't oversaturate the network. Knowing trunks and access ports, a big part of that is knowing how passing VLAN traffic across your network and how that is used. So it's a little bit of an understanding of how to utilize VLANs within your network. A VLAN is a virtual LAN or virtual local area network. So it is a way to segment a switch or a device into virtual switches. Instead of having physical 4 switches to have 4 separate networks, you can use VLANs to create 4 networks within a single physical switch. Doing this, it segregates your broadcast domains. That way, let's say you have a computer that wants to send out a request for an IP. It does a DHCP request. Well, it sends it out to everybody who's listening. So every device that is on the network that it's attached to is going to get a broadcast packet saying, hey, can I get an IP from you? If you had that across a couple of thousand devices constantly doing that, that could create a lot of excess traffic on your network. This allows you to segregate your broadcast domains into more manageable networks. A lot of times, too, it might not even be to where you might have 20 devices on one network and only a couple hundred on the other. And in essence, that's not a whole lot of data traffic. But sometimes it's used to logically separate those networks. So you could have your workstations on one network, your printers on another network, and your wireless devices on another network. So it allows you to have different subnets and IP ranges for each type of device, which is good for you to keep up with what's on your network. Hey, yeah, I know it's a printer IP, and that should be, in this range. Also, it will allow you to do rules on your firewall per network. So you could say, oh, I don't want any of my printers to be able to get out to the internet. Well, if you have them in a separate VLAN or separate network, then you can just block that network from passing across your firewall and allowing those workstation and wireless devices to pass out. So when you do VLAN, it's VLAN tagging. It uses the IEEE 802.1q. You'll also hear it referred to as .1q. And so even whenever you're dealing with Cisco and especially some of the older switches, you have to, if you want to use a VLAN on an interface, you have to go in there, and the command is switch port trunk encapsulation .1q. And that's how it actually denotes it in the Cisco text whenever you're typing it out to assign it to allow VLANs to cross that port. So you'll hear .1q not only just from somebody using it as an acronym, but also in provisioning in some switches. It's not really important to know that it's 802.1q, other than if you hear somebody reference that, that's what they're referring to. And so another way that you'll hear, well, I'm not going to dive into it in this training, but I did want to bring it up, that there is another way to divide up networks other than VLANs. And so you'll see, even as we do things, they're divided up in VRFs, virtual routing and forwarding. And so this segregates the traffic even more than just a VLAN, to where a VLAN is still going to be connected across, usually to a layer 3 switch that they can all route across. Well, whenever you have it in a VRF, everything that is within that VRF is even segregated itself. One thing this allows you to do is you can actually have the same network IP scheme in one VRF, and in another VRF use that same IP scheme, because they never touch each other. Their route tables are separated. So routing for one VRF is completely independent from routing from another VRF. So on a typical network, you'll see that a switch will have all the ports set up exactly the same. So if you pull a switch out of the box, all the ports are configured by default. You can plug stuff up and they can communicate. So they're all connecting to each other across the switch. The switch is in a default configuration, which is typically using VLAN 1. Usually you don't see VLAN 1 on a port, but VLAN 1 is the default interface that most switches will put everything on to communicate. So with this scenario, all these would be on the same broadcast domain, on the same network, would get the same IP scheme and could connect out. So they are able to connect and communicate directly. They don't have to go through a layer 3 router or anything like that because they are all on the same network. So if you want to segregate traffic, this is when you need to define the VLAN that you want to use for your network. It's a little bit of planning for you to kind of decide what VLANs that you want to utilize for each type of network. So for our example, we're going to use VLAN 10 workstations and VLAN 20 for the printers. In the switch, we would have to make sure that we define those VLANs in the database. So that's kind of a key thing that you have to make sure that you understand, that just because you assign a port a VLAN doesn't necessarily mean that that switch knows how to deal with it. So switches have a VLAN database. And in that database, it's just saying, hey, I know this VLAN is part of my network that I can communicate and inspect those taggings and handle it. That's a key thing to know, is all VLANs that you're going to use need to be added to that VLAN database. I'm not going to get into the details of the VLAN database or how to add that because there's a lot that goes into that. The virtual tables that push out server client side, VTP, and other aspects of it. And we'll do that in another training. But it's suffice to know that the switch, we've configured it, that it has VLAN 10, VLAN 20 assigned to it. Knowing this is how we're setting it up, computers and printers, for that matter, don't know anything about VLANs. They don't understand .1Q. They don't know what a VLAN header tag is. In packets that go to a computer, you know, most of you, I'm sure, are familiar with like a TCP packet. It's got a header, body, and so forth. Well, whenever you deal with .1Q, it actually adds another bit in that header that handles and specifies VLAN tagging. Well, computers don't understand that, typically won't be able to handle that packet. There are devices that are set up to be able to handle VLANs passing it. For the most part, computers and printers don't know how to handle them. Since they don't know how to handle it, you can't just pass that VLAN down to it and the computer know, oh, I need to talk on VLAN 10 and the printers need to handle VLAN 20. So what happens is these are set up as access ports. So this is the first part of it, is an access port. An access port is a port that on the switch side has been defined as part of a VLAN. So on the switch, we'll say switch port access VLAN 10. And so now that port understands that it is an access port that is designated for VLAN 10. So what that means is any traffic that comes northbound to it from the computer, once it hits that switch port, that switch then adds that .1Q tagging VLAN 10 to it and then sends it out to the backplane of the switch to be routed. Any traffic that is sent down to that for VLAN 10 will hit that port and it will strip that tagging at the port and send out down to the computer that traffic that does not have a tag on it. Now that's important to understand because I have to realize that everything that you attach to that port is going to be, all of its traffic, since it's an access port, is going to be on VLAN 10. So you plug in a computer to that port and now it's on VLAN 10. You unplug that computer and you plug a printer to it. Now that printer, because it doesn't know anything about VLAN tagging or anything, it's just going to route out and the switch is going to tag that traffic as VLAN 10 that goes from the printer out, and anything that's destined for VLAN 10 will now get to that printer. So at the port is where that VLAN tagging is stripped. So a packet that comes into the switch that's on VLAN 10 comes in, it hits those two ports that are part of that VLAN. It sends that packet down to both of them. If it's a broadcast packet, knows exactly which MAC address it'll route to the correct computer. But that at the switch level, that packet no longer has that VLAN 10 in it. So that the VLAN packet tagging is removed at that switch, and that packet is carried down without that tagging to the devices. And in reverse, everything will come up as a packet. As soon as it hits that interface, it gets tagged with the appropriate VLAN and then passes out. So this is kind of what a port would look like in a Cisco switch that has VLAN tagging. The workstation, switch port VLAN 10, of course we define that it is a switch mode access, and the access VLAN is 10. And the same thing with the printers. Same thing, you're just defining it as VLAN 20. The other side of it is a trunk port. And so it is a port that is designated as a switch port mode trunk instead of access. With the trunk, the biggest difference is that the trunk port will pass that VLAN tagging. It does not strip it. It is kind of garbage in, garbage out. So it has packet come in for VLAN 10, and it's going to pass it down and send it and keep that tagging in place to that far side device. So typically this is where you'll see trunks being used between your different switches or between a router and a switch. You'll see trunks being used between switches and, say your virtual hosts, because you might have multiple networks that a virtual environment will have networks designed to it for the guest. So if the device knows how to handle .1Q tagging, then you can set it up as a trunk. With this, the biggest thing that you'd use this for is to pass multiple VLANs across the network. So instead of having an access port on this router and then it passing down and having to define an access port on this switch to pass one VLAN, you could set up a trunk, pass multiple VLANs across it, because it's just going to take that VLAN traffic, it's going to tag it, send it to the other end, keep that tagging, and then the far side switch will then need to have that VLAN in its database and be able to handle the traffic and route it where it needs to go. If you wanted to send a VLAN 10 workstation that's hanging off the second switch, then it could ride across this trunk, still has VLAN 10. There's another trunk between this switch and that switch. It can pass that across and then come out as an access port onto a computer at the far side as such. So VLAN 10 would then route back. If it's gateway, it has to be on the same network, so it's at layer 2. That's an important thing to understand too, that VLAN tagging is at the layer 2 and not layer 3. If you pass VLAN 2 across all of this, then it can communicate directly to this gateway or the router and use it as a gateway across all these devices. One thing too that I've seen people kind of mistaken for is a trunk as a port channel. A lot of times you do see port channels set up as a trunk because of the port channel is giving you redundancy up to multiple devices, and it's not going to a single device. So a lot of times you do see that, but they're two totally different things, because a port channel can be set up as an access port as well. Actually done that several times, but typically you'll see most port channels set up as a trunk. But just don't confuse that a port channel and a trunk are one and the same. They're two totally different technologies for two different things. Another thing with trunks is we're talking about it passes traffic that has got the .1Q tag on it. Well, what happens if there's something that's connected to one of these switches that doesn't have any tagging on it at all? It doesn't have any .1Q tag on it, and you still want it to ride that trunk. What you can do is, on a trunk, you can do something that's called native VLAN. So you can assign that trunk between the two of them that say anything that doesn't have a .1Q tag associated with it, tag it with this VLAN. And then it will then pass across this trunk with that VLAN on it. Sometimes you'll see that for devices that are on the management level and they're not really doing .1Q tagging on it. They'll say, okay, anything that's not passing this .1Q tag, just assign it to the management VLAN and it can cross. All right, so kind of the summary of what we've gone over is, for access ports, they remove those VLAN tags from the packets going across to the device that port's connected to. So all VLAN .1Q tagging are removed at the port itself. And then any traffic that's coming from the device that hits that port on the switch that is defined as a access gets that VLAN tagging put into the header with the associated access VLAN that is defined on that port, to where a trunk is just pretty much a pass-through. It passes the VLAN tagging that's contained within the packet across to the connecting device. But when you do it as a trunk port, the other device has to understand and know how to deal with .1Q tagging and can read that header and can pass that traffic. And not only that it can understand it, but it also needs to have that VLAN within its database as well, or else it will just drop that packet entirely.